Hey everyone, I'm Grace from Red Hat AI, and today we're going to talk about Enterprise Gen AI Inference on the Red Hat OpenShift AI stack. To take you through it, I'm going to show you an exclusive demo from this year's Red Hat Summit. Let's get into it. So here's the big picture. At the top, we have AI Gateway. Think of it as a control tower. It manages security, resources, and routes every request to the right model and hardware combination. It also works with cloud-based models like Anthropic, OpenAI, Gemini models, so your team gets one unified control plane over everything. Below that is the inference layer, powered by vLLM, an efficient inference and serving engine for LLMs, and llm-d, a distributed inference framework that helps scale and optimize LLM inference in production. So let's start small. Say an internal team has just developed a RAG chatbot, basically an AI-powered search tool over their company's internal knowledge base. They're on a single GPU, and thanks to vLLM's KV cache management with page detention and continuous batching, they're getting great response times right out of the gate. They can handle a moderate amount of users, but the chatbot becomes popular, more people start using it, and latency creeps up. GPUs are still scarce, so the team looks to quantization. Quantization is a model optimization technique that reduces the memory footprint of the model while retaining the accuracy. This way, the model takes up less space on the GPU and often speeds up response times, giving the team better performance on the same hardware. They could choose to quantize their own models with vLLM's LLM compressor, or use models that have already been quantized and benchmarked, some of which can be found on the Red Hat AI Hugging Face. Let's say users are still complaining. Response times still aren't where they could be. Next, we'll look at speculative decoding, a technique used to speed up LLMs using a draft and verify approach. Here's how it works. You put a small, lightweight draft model in front of your main model. The draft model rapidly generates candidate tokens, and the main model just has to verify them. It's much faster to verify than to generate from scratch, so your overall token generation improves significantly. By now, the RAG chatbot is a hit across the whole organization, and the engineering team wants a code assistant too. Now you have two AI workloads sharing the same GPU and things are getting complex. The natural move is to scale horizontally, spin up more replicas, put a load balancer in front, and use round-robin routing. But AI workloads aren't like regular web traffic. A 5-token question like, "Where's the coffee?" is nothing compared to summarize this 120-page PDF. Round-robin routing treats them both the same and ends up being wasteful. There's also a smarter opportunity being missed. If 10 people all ask, "Where's the coffee?" they should all be routed to the replica that already has cached that response. Otherwise, P95 time to first token improves, but P99 remains high due to cache misses, and prefill compute is wasted. This is exactly why llm-d exists. llm-d acts as an inference-aware router. Instead of round-robin, it routes requests to a replica that already has cached a similar request. It also avoids overloaded replicas and balances in-flight user sessions. You're reusing work instead of redoing it, while serving your RAG chatbot and your code assistant more efficiently on the hardware you already have. Now let's go one level deeper for the agentic workflows and high-throughput use cases. The inference process actually has two distinct phases: prefill, where the model reads and understands your input, and decode, where it generates its response. With prefill-decode disaggregation, you can split these two phases onto separate hardware. That means you can scale each one independently, based on demand and hardware optimization. Add llm-d's inference-aware router on top of that, and your scheduler becomes dramatically more efficient. And underpinning all of this is our model catalog, a growing repository of validated, optimized versions of the most popular open-source models, as well as models our customers have specifically asked us to validate for them. You can filter by task, by provider, and when you click into any model card, you can get detailed information to help you decide if it's the right model for your specific use case. And that's it. From a single RAG chatbot to a disaggregated, inference-aware, multi-workload platform. If you want to dig deeper, check out some of the links in the description and subscribe for more videos. Keep an eye out for next year's Red Hat Summit. Thanks for watching, have a great day.